Okay, welcome back, class. This is the third video for today. I'm gonna wrap up with the concept 2-5 and 2-6. Okay, if you look at concept 2-5 and you will see measures of variability, we just finished range. Range is the max number minus minimum number, right? So if you have a data set 1, 2, 3, 4, 5, what is the R value? 5 minus 1 equal 4. That means numbers vary, right? If you want to know more about their differences, you will move to the next level. That is the variance. Now you are looking at two different sides, right? So if you look at the left side, the variance for the population, and variance for the sample. So if you collect data from the entire group, you need to go with population-based variance. If you are dealing with sample data, you need to go with sample-based variance. First, variance for the population is written as sigma square. Don't get confused, the Greek sign of sigma. That is the summation that add all the numbers. However, lowercase Greek letter, this is called sigma, and square sigma. So sigma square, that is the variance equation for the population. So 1, 2, 3, 4, 5. You collect data from the entire group and you got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then this is population. If you want to find out their differences in the population, you have to use variance, sigma square. The equation is sigma square is sigma parenthesis x, each value x number minus mu. Mu is the mean for the population. However, you already learned that mean for the sample is called x bar. Right? So remember this equation to find out numbers differences in the population. Sigma parenthesis x minus mu parenthesis and square. However, if you want to see variance for the population, which is written as s square instead of sigma square, equation looks very similar. The only difference in this equation is denominator right there is capital N, total case of the numbers, right? So here we have 5 cases. 1, 2, 3, 4, 5 population data. If you look at sample data set here, you have 1, 2, 3, 4, 5. Let me right there. So now you have a s square, which is a variance for your sample data. Equation is a little bit different, okay? N minus 1. So denominator is less than denominator in the population. I will explain about it later, okay? So just try to memorize variance. So let's practice how to calculate variance for the population. You have a data 1, 2, 3, 4, 5 from the population. So I will write down 1, 2, 3, 4, 5 right there. And now you need to calculate the mean for the population. So 1, 2, 3, 4, 5. So mu equals 3. So let's apply this formula to calculate the variance for the population. So I put mu right there, 3, 3, 3, 3, 3, to calculate x minus mu. 1 minus 3 equals negative 2, right? 2 minus 3 equals negative 1. 3 minus 3, 0. 4 minus 3, 1. 5 minus 3, 2. So I just calculated the value for x minus mu right there. Now, you need to, this is the first step, x minus mu. Next step, you need to square all the values from x minus mu. So I am going to square this value. Negative 2 square equals 4. Negative 1 square equals 1. 0 squared equals 0. 1 squared equals 1. 2 squared is 4. Right? So step number 1, x minus step number 1, you need to calculate this one, x minus mu. Next, step number 2, you need to square for the value of x minus mu. Step number 3, you need to add all of those values that you calculated from x minus mu and squared. So let me add x minus mu squared, 4. 1, 0, 1, 4. I add all of those values and I got 10. Next, let's calculate sigma square. That is the variance for the population. So I got 10 over case number capital N for population 5 equal 2. So if I ask you, calculate the variance for the population using this data set, your answer should be 2. Next, this is the variance. Next is standard deviation for the population. Simply you put a square root on the value of the variance. So square root of 2 equals 1.41. 1.41. That is the standard deviation for population. Okay, why do we put a square root? I'm sure that should be your question. Okay, variance is a value that each number is changing from the mean. However, when you collect data through testing, evaluation, measurement, we make errors. Errors. I still remember I explained about errors. My height is 5'6". Depending on when I go to hospital, when I'm measured for my height is changing just because of the errors. It could be testing errors. and the tool's errors is not really a good tool to measure height, or testees errors, such as I lowered my body so they didn't get my correct height, right? So to compensate those errors in the process of data collection or in the process of statistics, we compromise those errors by putting a square root. If you put a square root on a whole number, that number will be smaller. For example, you made 100 errors, and I will ask you, well, are you sure you made such a mistake? You might say, well, I'm not sure. I tried my best, but, well, just because some people didn't follow directions, but I got 100 differences, then I will tell you, well, let's compromise this big number to reduce error rate. So I'm going to put square root right there. Your error will be 10 just by putting a square root. Okay, so now you learn one thing: variance versus standard deviation. Which one is smaller? Always standard deviation is always smaller, because if you can calculate a variance, you can calculate standard deviation by simply putting a square root on the value of variance. So what if your variance equals 144? What is the standard deviation for the population? That is square root of 144 equals 12. So standard deviation is always smaller than the variance just because of the square root, right? Let's move to the sample data. So we collect data from the huge population, and we collect data, and we made a small sample, and then we got the data 1, 2, 3, 4, 5. Okay, and then you need to put you gotta use this equation for variance for the sample. S squared equals sigma x minus x bar parenthesis squared over n minus 1, n minus 1, m minus 1, right? m minus 1. Then you will follow this equation again. You have 1, 2, 3, 4, 5. The mean for the sample data is 3. 1, 2, 3, 4, 5. The average is 3. So x minus x bar value, negative 2. 1 minus 3 equals negative 2. 2 minus 3 equals negative 1. 3 minus 3 equals 0. 4 minus 3 equals 1. 5 minus 3 equals 2. And now next step, you need to square the value of x minus x bar the same way you did here, x minus mu squared. So you will get 4, negative 2 squared equals 4. Negative 1 squared equals 1. 0 squared equals 0. 1 squared equals 1. 2 squared equals 4. If you add step number 1, x minus x bar, step 2, square, and step number 3, add all of those values from x minus x bar square. You got 10. Then you need to use equation again. You just found out the variance for the sample data. S squared equals 10. What about the simple S? That means standard deviation for the sample is square root of 10 equals 1.58. Next, before we wrap up this concept, you might have a question. Why this is just simple n? Why this is n minus 1? n minus 1. Which one has a greater variance? Even we use same data, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Standard deviation for the sample is 1.58. Standard deviation population is 1.41. Even raw data are the same. The reason is your denomination right there, denominator is different. So you allow some errors when you collect data from the sample. To compensate your errors, you make this denominator a little bit less. For example, you collect data from population. So you got all the data from the population. Nobody is left out right there. So you don't make any testing errors. You got all the right numbers from everyone. However, here, sample, well, you might got really extreme numbers from population, unfortunately, right? So you might have made bigger mistakes in data collection. To compensate those errors, you make your denominator smaller, right? Smaller. So you got 10 over 5 equals 2. 10 over 4 equals 2.5. So your standard deviation, including testing errors or measurement errors, your standard deviation for sample is always bigger than population. This is a population. This is a sample. Okay, so you learned something from concept 2-5. We have two different samples right there, equations as well. Variance, standard deviation for population. This side is a sample. Depending on your data set collected from population or sample, you have to use different formula. Equation right here. If you look at the equation closely, you will see some difference here, n and n minus 1. The only reason to put simple n stands for the case for population. Smaller n, lowercase n is the case for the sample. Right there, right there. To compensate any testing errors and to standardize your errors, we make denominator smaller. Then you allow some testing errors. Okay, so even we have a 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, same data set. Variance is the same, right? However, when we standardize those differences, we need to consider the data characteristics. One is from the entire group, one is from sample. So you might make mistakes from the sample data. So you allow more deviation. For that reason, you put n minus 1. For your test, well, you have a class note, you have a formula, so you don't need to worry about how to calculate. And Friday, I'll try to cover how to use SPSS to calculate variance and standard deviation. I will give you small data set so you can calculate by using this equation the way I did, x, just putting an x, a mu, x minus bar, right? So you can calculate it by hand. But what if you have a huge data set? Then it might be impossible to do it. Then you can use Excel or SPSS. So those who are motivated to learn and practice for yourself, just go to concept number 2-8. 2-8. That will be practical questions. And data set is already given for you, so you can just practice, and I will upload all the answers for you so you can make sure you fully understand the concept of measures of central tendency, concept of variability in terms of range, variance, standard deviation for population and the sample. Okay, thank you so much for watching 3 videos today, and Friday will be the test review, and I will briefly introduce how to use SPSS using your own computer. And please don't forget to download SPSS from the site that I already provided, or if you cannot access those link, please use CSSB virtual lab to take the test or practice for yourself. Okay, thank you so much, and I hope to see you on Friday. See you later. Thank you.